Hi everyone, and welcome to the first video on my channel. I'm going to be doing the walkthrough for Mock Set 1, Paper 1, Higher. Okay, so I need to change these, or I would suggest changing these into top heavy fractions in proper fractions first of all. So 2 times 5 is 10, add 3 is 13 over 5. Subtract 1 times 6 is 6, add the 5 is 11, so that's going to be 11 sixths. Now we need to change these so that the denominators are the same. The lowest common multiple of 5 and 6 is 30, so we need to make them into 30ths. Remember, this is a non-calculator paper, so you can't just type it into your calculator. 5 times by 6 gives me the 30, and 6 times by 5 gives me the 30. Well, 11 times by 5 is 55, 13 times by 6. Okay, so let's do some quick working out. 6 times 3 is 18, carry the 1. 6 times 1 is 6, add the 1 is 7. Okay, and that makes sense because 5 times 13 is going to be 65, and then add another 13, 78. Then we've got 78 subtract 55. 8 take away 5 is going to be 3. 7 take 5 is 2. So 23 over 30. Now 23 is a prime number, so these two are going to be co-prime, which means you can't simplify any further. So 23 over 30. Okay, next question. Now, this question has given us a graph. Notice the y-intercept here. It's not going through the origin. This phone calls cost y pounds. So this is the price up here, or cost if you like, for x minutes. So this is the number of minutes, the x-axis. The graph gives the values of y for values of x from 0 to 5. Give an interpretation of the intercept of the graph on the y-axis. So in interpretation, we know this is the y-intercept, but interpretation means give like a real world, explain in real world terms what this y-intercept means. And so this is going to be usually what's referred to as like an initial charge, or an initial cost. So regardless of however many minutes you spend on the phone, you're always going to have to pay this initial cost, and that looks to be halfway between 0 and 1, so 50p. So the initial charge, no matter how many minutes you're on the phone, is going to be 50p. So it's showing the intercepts of the graph on the y-axis. The y-intercept on the graph is the initial cost that will have to be paid regardless of how long the call lasts. Okay, and I'll give an interpretation of the gradient of the graph. Now, the gradient, one way of thinking about the gradient is if you move along one unit to the right. So, for instance, if we go from 1 to 2, how much the y value, the y coordinate, is going to increase. Okay, so I could look at that there and figure out the gradient quite nicely, just going from 1 to 2 and looking at how far it's gone up. But again, if we think about a real world interpretation of that, if I go up by 1 minute, how much is that going to cost? Okay, so how much per minute is a call going to cost? So the gradient of the graph is the cost per minute of a call. Okay, and now we have to find out the equation of the straight line in the form y equals mx plus c. So m is our gradient, so we're going to have to work that out. C is the y intercept Okay, now the gradient, like we said previously, I could look at just this x coordinate for 1 here, look at the y coordinate, and then go along 1 unit, so not 1 square or half a square, go along to 2, so 1 unit, and how far the y value is then increased. That will tell me my gradient. Now, another way of doing it, and probably a more accurate way of doing it in this case, because I can't be sure it exactly goes through 1. It does look like it though, so you know that is a valid method there. But another way to do it is to use your points, so 2 key points that you know. So we know the initial cost, the y-intercept we looked at before, that looks to be 0 and 0.5. And then for a straight line, you normally want to use the furthest possible point that you can to give you the most accurate answer for your gradient. So for instance, if we look at this top right point here, that's gone right to the top right corner there, that is 5 on our x, and then our y is going to be 8. Now, you sometimes refer to this as a change in y over change in x. So 8 subtract 0.5 divided by 5 subtract 0. Okay, so that is going to be 7.5 divided by 5. Okay, now again it's non-calculator, so that's going to be, well, you're going to have to remember how to divide decimals. Now fortunately we're not dividing by a decimal, so we can just do our bus stop method. How many 5s go into 7 is going to be 1, remainder 2, keep your decimal point in there. How many 5 are going to 25? 5, so 1.5. Okay, and if we look at the previous way that I explained about finding the gradient, we've got the gradient here as 1.5. If we go along from the x-coordinate of 1 to the x-coordinate of 2, and if we go up, it's gone up from 2 to 3, so that's a difference of 1, and then it looks to be again 1.5. Okay, so now we just need to plug our values into this. So y equals, could say 1.5x. What is better is to use fractions instead of decimals wherever possible. So 3 over 2x plus a half. Okay, for 0.5. Okay, next question. ABCDE is a pentagon. Work out the area of ABCDE. Okay, so at first glance, this question looks very straightforward. Okay, it's just finding the areas. Now the area of this rectangle here, 4 by 8, let's do a quick sketch. That's quite easy. 4 times 8 is 32. Now the more difficult part is working out the top triangle here. So we need to know the height of this triangle. We need to know the height from there to the base of that triangle that we've drawn. Now the way to do this is basically to use Pythagoras. There may be other methods, but the most straightforward and the most obvious at the moment is using Pythagoras. Now the whole base is 8, so that means half to the midpoint here is going to be 4. Now what we need to then do is use Pythagoras, because this must be a right angle here. 5 squared subtract 4 squared, and then you need to square root your answer. So that's going to give me square root, and this is a Pythagorean triple, so you may know this off by heart. 25 subtract 16 is going to be square root of 9, which is equal to 3. So this height here should be 3. It's a 3, 4, 5 triangle. Once you've got to that point, quite straightforward. Again, I'll just do a quick sketch of the triangle. So we've got 8 all the way along the bottom, and it's got a height of 3. Half the base times the height for a triangle, so half times by 8 times by 3. Half of 8 is 4, 4 times 3 is 12, and then we've got 32. Add 12, which is 44. Okay, on Monday, Tarek travelled by train from Manchester to London. Tarek's train left Manchester at 8:35. It got to London at 11:05. Immediately, I'm going to try and work out the difference between these two, because I'm probably going to need that in a second when I read the rest of the question. So I'll work that out now. So 8:35, and we need to get to 11:05. So if I add on, it's going to be 25 minutes to get to 9. 5 minutes is 40, add another 20 on, so 25 mins. And then we need to get from there to 11 o'clock. That's going to be 2 hours. Okay, or 120 minutes then to 11:05, which is just obviously 5 minutes more. Now in total for that journey it's 2 hours and 30 minutes, or 2.5 hours. On Wednesday, Gil travelled by train from Manchester to London, so the same places. Also left at 8:35 but was diverted. The train had to travel an extra 37 miles. Okay. We've also got, just going back to the first part, that Tarek's train was 110 miles per hour, so this is looking like a speed distance time question. So an extra 37 miles, but we have to work out the distance from the first bit to then add that on. The train got to London at 11:35. Now that time difference is going to be a lot easier to work out because it's exactly the same in terms of minutes. So basically what you're thinking about is how can you get from 8 to 11. 9, 10, 11 is going to be 3 hours, and we would expect it to be longer because his train has been diverted, so I'll just put G there for Gil, T for Tarek. Okay, work out the difference between the average speed of Tarek's train and the average speed of Gil's train. Okay, now we've already got the average speed of Tarek's train. We can't work out the average speed of Gil's train until we've got the distance and then added 37 on. Okay, now the way I remember the formula for speed or distance, or speed distance time, is in Europe quite often it's kilometers per hour. Okay, now this says kilometers divided by hours, and this is how it's written, kilometers per hour, kilometers divided by hours. So that means that, well, that is a speed, and on top of our fraction is distance, and on the bottom is time. Okay, unit of time, hours. Now you may also learn this as a triangle like this. You may have seen it like that. It's another way of doing it, okay, rather than manipulating a formula or an equation. Okay, so we need to work out the distance. Now if we're going to work out the distance for Tarek's train, we put in the speed as 110. Now that's in miles per hour, so our units need to be in miles and hours. Now we want to work out the distance. Time is in minutes and hours at the minute, but remember, like I said before, that's 2.5 hours. So on the bottom here we've got 2.5 in our equation. Now to get the distance we need to multiply through by both sides by 2.5. Okay, to cancel out the divide by 2.5, okay, because they're inverse operations. Now I'm just going to have to move this along over here. So on the left hand side we've got 110 times 2.5, and that's going to give me the distance. Okay, so 110 times by 2 is going to give me 220, and then the half, 0.5, so half is going to be 55, so add 55, that's going to be my distance still. 220 add 55 is 275. Now remember, that's in miles. 275 miles. Now Gil's train down here did an extra 37 miles, so we need to do 275 add 37. Okay, well 5 add 7. We'll add the 30 on first of all, that makes the most sense. So add the 30 on, we get 305. Add the 7 on, we get 312 miles. Okay. We need to, again, we'll remind ourselves we're working out the average speed. So we've got the distance for Gil, we've got the time, alright, speed is distance divided by time. So take our distance, 312, divide it by our time, 3, and we need to work out the answer here. So we might need to do, well, I'm going to need to do a bus stop method. Okay, 3 goes into 3 once, 3 doesn't go into 1, so carry the 1 over, 0 there. 3 goes into 12 4 times. Okay, so that gives
his training, average speed of 104 miles per hour. Okay, because we've used miles and we've used hours, so miles per hour. 104. Work out the difference. Remind yourself of the question. Don't just write down what you've worked out between the average speed. So the difference, 110 and 104, is 6. And another way to do that could be using a table. Alright, so you could use a table to put in your speeds, distances, and times. Frank is going to cover the wall with rectangular tiles. Each tile is 60 centimetres by 30 centimetres. Straight away I'm looking at this and thinking, well, that's in metres. Centimetres, century, 100 cents in a dollar. There's 100 centimetres in a metre, so this is going to be 600 centimetres, and this is going to be 180 centimetres. I'm thinking that's going to be easier at the moment to change metres into centimetres. Okay, he's going to cover the wall with rectangular tiles, so I'm presuming the full wall at the minute. 3/5 of the tiles will be white, some of the tiles will be green, the rest of the tiles will be blue. Okay, now I think first things first, we need to figure out how many tiles are going to fit into, or onto rather, this wall. Now it's 60 by 30. Okay. Now, looking at it this way, so let's say 60 is along the bottom. It doesn't say which way these tiles are going, whether we can rotate them or not. And it says there are no gaps between the tiles down here. So let's do 60 along the bottom, so we could fit in 10 along the bottom here, because 60 will go into 600 10 times. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then how many times will 30 go into 180? Well, 3 goes into 18 6 times. So it will go in 6 times. So we've got 10 along the bottom and we've got 6 up. Okay. So 6 rows of 10. 10 times 6 is going to be 60. Okay. 1, 2, 3, 4, 5, 6. Okay. 10 along the bottom, 6 up, as I say, so 10 times 6, we can have 60 tiles. Now 3/5, so we need to do 3/5 times by 60. Now to work that out, we need to find 1/5. Okay, so 1/5 is 1/5 of 60. How many 5s go into 60? It's going to be 12. 12 times by 3. Okay, 12 is 1/5. How many 5s go into 60? Times your 12 by 3 to get 3/5, so that's going to be 36. So 36 tiles are going to be white. Should abbreviate that with a W. So that means the rest is going to be 60 subtract 36. Okay, can't do 0 take away 10, so carry the 1. 10 take away 6 is 4. 5 take away 3 is 2. So we've got 24 left. The ratio of the number of green tiles to the number of blue tiles will be 1 to 3. Okay, so use a bit of bar modelling. Okay, so we've got 1 there, and then 3 here. Green tiles to blue tiles. Now remember, green comes first, so green is going to be the 1, and blue comes second, so blue is going to be the 3. So we need to divide 24 into 4 boxes. 24 divided by 4 is going to be 6. 6 goes into each of these. So that means green is 6 tiles, blue is going to be 6, 12, 18 tiles. Okay, and there's our answer. So white is 36, green is 6, and blue is 18. So part B. Frank is told he should leave gaps between the tiles. If Frank leaves gaps between the tiles, how could this affect the number of tiles he needs? So if he leaves gaps, we're not going to be able to fit 10 in exactly along the bottom, presuming it's 60 width-wise and 30 vertically, these tiles. And again, we're not going to be able to fit 6 vertically. We're going to be able to fit fewer in than that. So how could this affect the number of tiles he needs? Essentially, this could mean that he will be able to use fewer tiles. And then in turn it will reduce the cost, won't it? 6. Okay, distance time graph. On Monday, Ria delivered a parcel to a hospital. The travel graph represents Ria's journey to hospital. Ria left home at 1 o'clock, so I'll put that on my time axes. She drove for 30 minutes at a constant speed of 40 miles an hour. So she drove for 30 minutes here, which means this is going to be 1:30, because she then stopped to take a break. Now that flat bit is when the distance isn't increasing, so that's obviously when she stopped. Now what that means is we can then fill the rest of this in. So this will be 2 o'clock. I'll keep it in 24-hour format as they've done. So that means this is going to be 2:30. This is going to be 3 o'clock. So every 4 squares is an hour. So then this will be 4 o'clock. And then at the end we've got 5 o'clock. Ria then drove to the hospital at a constant speed. Okay, so this is a driving to hospital at constant speed. She was at the hospital for 30 minutes. So we're just going to be at the hospital until 3:30. So we need to fill that in with a stationary, with a straight line representing Ria being stationary. She then drove home at a constant speed of 32 miles per hour. Show that she does not arrive home before 4:30. Okay, now 4:30 is here, so we need to show that she arrives after 4:30. Now again, we need to use our speed distance time formula. So speed is distance divided by time. So what we're going to do then is drives home at a constant speed of 32 miles an hour. So substitute that in. 32 equals, now her distance, we need to look at the distance here. Now we don't have any distances currently, so I think we're going to need to go back and look at this bit here to work out the distance. Okay, so we'll do that up on this section here. So 40 miles per hour is equal to, and we need to know the distance, so I'll leave that as distance, divided by time. Now her time was 30 minutes, so in hours, because it's miles per hour, you have to have the same units, that's going to be 0.5 hours. Now multiply both sides by 0.5, and then that will cancel out this divide by 0.5. So 40 times by 0.5, remember 0.5 is a half, so you're just halving your 40. Half of 40 is 20, so 20 is the distance. Now remember that's going to be in miles because it's miles per hour, so that's 20 miles. Okay, so we know that bit there is 20 miles, which means that's 10, and each of these squares then must be 5. 30, and in 2 squares is going to be 10, like we say, 40. Okay, so in total the distance to the hospital was 40 miles, which is what we wanted. Now speed is distance, so 40 miles divided by time. We need to work out what time it's going to take her to get back, and then we can add that on to 3:30. So what we're going to do here is similar to what we did up here actually, apart from we're not going to be using, we're not going to be timesing by 0.5, we're going to be timesing by time, which is fine. You can do that. That will just move where the time is in our equation. Just checking the focus on this camera. Okay, it's focused here, but it's not focused here for some reason. So the focus is happening over here, so I just need to be aware of that just when I'm writing on different places. Okay, 32 times by time. So we've got 32 times by the time equals 40. Now we need to isolate time. We need to get time by itself. Time equals something. That's what we want. So we need to divide by this 32. Divide by 32, and that will give us just time by itself over here. And then time is going to be 40 divided by 32. Now remember, we don't have a calculator, so I'm going to have to simplify that. Now I know that these are both multiples of 8. 40 divided by 8 is 5. 32 divided by 8 is 4. So that is going to be
4 goes into 5 once, and there's 1 remainder, so 1 1/4. Now remember, that's hours, isn't it? Okay, because the speed was in miles per hour, and this distance was in miles, so this is hours. So 1 hour 1/4. Now that is going to be 1 hour and 15 minutes. 1 hour 15 mins. Now we need to show on the graph what time she's going to be home for then. So 1 hour is going to be 4:30, and then you've got to add on the 15 minutes, which is going to be here, halfway between 4:30 and 5 o'clock. Okay, so use a ruler, and it's going to go here. Now remember, this is a show that question, so you can't work all this out in your head and then do this. If you just do this, there's a high likelihood that you won't get all the marks, because you've got to show where your workings come from. You've got to show these steps, and you could cut out some of those steps, for instance. So you could not write times by time and just do 32 times time is 40, or you could go straight to time equals 40 divided by 32. Okay, right, so there we go, we've shown that. Now, work out an estimate for the value of this. Now, key word here is estimate, and we can only estimate this because we don't have a calculator. Now, the best way to do this is to round everything to one significant figure. So first significant figure is 4. Look at the next one, it's a 3, so we're going to round that to 40 times by. Now, first significant figure is a 9. Look at the next number, it's a 9. Okay, so we go up, that 9 it goes up to 10 if you like, and we carry that 1 over to the hundreds column, so it becomes 100, square root of 100 divided by. That's my first significant figure. Don't be fooled into thinking the first one is the 0. The zeros initially don't count until you get to the first non-zero number. Then you can count your zeros. So then look at the next number. It's a 9. So the 1 goes up to a 2. So that's going to be divided by 0.2. Also, be aware 0.2 is a fifth. Okay, right. 40 times by square root of 100 is 10 divided by. I'll leave it at 0.2 for the moment. 40 times by 10 is 400 divided by 0.2. Now, what we could do is different ways of doing this. I could change that into a fraction and do it that way. What I'm going to do instead is use an equivalent fraction, because this will also show you how to divide decimals generally. So times top and bottom by 10, because I can't divide by decimal. That will give me an equivalent fraction, so it doesn't change the value. So then I get 4,000 divided by 2, which is a lot easier to work out and will give me the answer straight away. So that will give me 4,000 divided by 2 is 2,000. Now if I get my calculator and type that in, that should be very, very close. Of course it is an estimate though. Okay, 43.2 times by square root of 99.05 divided by 0.193. Yes, just over 2,000. Okay. Right, next question. Shape A is translated by the vector 4, -7. Now 4, -7, remember this is your x and this is your y in terms of direction. So that means 4 to the right. Now the way I remember that as well is if you think about a graph, your numbers are on your x, they go 1, 2, 3, 4. They increase to the right, okay, and likewise on your y-axis they increase going up, okay. So in terms of, I could think about these like adding, all right, and I could put a plus there to remind me that that's like adding 4, okay, to my x direction. X comes first, y comes second. If you can't remember which way around it is, think about the alphabet, x, y, z. -7, so this is going to be 7 down. It's like subtracting 7 in your y direction. Okay, so shape A, and then I move that 4 right and 7 down to make shape B. Shape B is then translated by this vector, so -3, -2, and by the same token that's going to be 3 left. It's like subtracting 3 in your x direction, and 2 down. Now describe the single transformation that maps shape A onto shape C. So we're going from this shape to this shape. Think about just your x coordinates and what's happening to them. okay, or your x direction, 4 right and 3 left. So in total, that's a net. So if I go 4 right, I could start at 0 if you like on my my axes are drawn. 1, 2, 3, 4, and then 3 left. 1, 2, 3. So in total, that's a net of 1 right. Okay, so 1 right, and then do the same with our y translation, or translation in the y direction, I should say. There's going to be 7 down, and I can't really do that on this axis. I've drawn the set of axes. 7 down and 2 down is going to be a net of 9 down in total. Okay. And another way of doing this is basically just adding these coordinates together. 4 add -3 is 1. -7 add -2 is -9. Okay, so it's going to be a translation again, because these are all translations. Translation by the vector 1, -9. Okay, question 8 done. A company orders a number of bottles from a factory. The 8 machines in the factory could make all the bottles in 5 days. All the machines work at the same rate. The 8 machines in the factory could make all the bottles in 5 days. Okay. All the machines work at the same rate. For 2 days, only 4 machines are used to make the bottles. From the 3rd day, all 8 machines are used to make the bottles. Okay. Now this is going to be inverse proportion. Okay, so 8 machines will take 5 days. 8 machines is 5 days. All machines work at the same rate. But obviously if we reduce the number of machines, this is going to increase, isn't it, from a logical perspective, which means it's going to increase in proportion. So if I divide that by 8, this side, I've got to times this side by 8. So for instance, it would take 1 machine 40 days. Okay, all machines work at the same rate. For 2 days, only 4 machines are used to make the bottles. Okay, so for 2 days, only 4 machines. So 4 machines divided by 2 is going to mean I times by 2 on this side, so 10 days. 4 machines is 10 days. So for 2 days, now 2 days out of 10, do it over here, 2 days out of 10 days, 2 divided by 10, simplify that, divide top and bottom by 2, that gives me a fifth. So I would expect that in 2 days they've only made a fifth of the bottles they need to make. So we've got 4/5 left. From the 3rd day, all 8 machines are used to make bottles. Okay. Work out the total number of days taken to make all the bottles. So from the 3rd day, all 8 machines are used to make the bottles. They can make them in 5 days, but we need them to make 4/5 of the bottles, these 8 machines. So 8 machines, to make 4/5 of bottles, we need 4/5 of 5 days, because they don't need to make all of them, they just need to make 4/5. Is going to be 4. 5 divided by 5 is 1, times by 4 is 4. So the 8 machines need 4 days to make 4/5 of the total bottles. So 4 days, add the 2 days, that's going to be 6 days. Okay, it's a little bit of a tricky question, that, because you've got to think about how many bottles they're going to make in that number of days. So it's kind of inverse proportion, and you're working out the proportion that 2 is of 10. Okay, right. Down here we've got 64 to the power of -2/3. So what we need to do, the negative part here, I want to get rid of that first of all. That's going to make it 1/64 to the power of 2/3. Now then what that means, deal with the denominator, that's going to be the cube root of 1/64. And then we've got that squared. So we need to work out the bit in the brackets. Cube root of 1 is 1. and then we need the cube root of 64. So what number could I cube to get 64? And it's going to be 4. And then we need to square that. 1 squared is 1, 4 squared is 16, so 1 over 16 is the answer. Okay, so Joe measured the heights of students in 4 different classes. Drew a cumulative frequency graph and a box plot for each class. Okay, so we've got these 4 here. Go up to 30 and they've got the heights along the bottom. Now looking at the medians for each of these, they're very slightly different, so the medians will be halfway on cumulative frequency between 0 and 30 in this case, so 15. Okay, so that's, this first one's got a median of 160, half between 140 and 180. This has got a median of about, well, if that's 150 and that's 160, it's going to have a median of about 155. And then C has got a median of 170, and D has got a median of 160 again. Okay. Right, and then we've got these box plots down here again with different medians. So if we just turn over and have a look at the question, it says match each cumulative frequency graph to its box plot. Okay, now we go back to these cumulative frequency graphs on the box plots. Just going off the medians and the medians of these box plots, that would mean that B is going to have to be X because the median is about 155. So X is going to have to be B, which note it here for the second. And then C is going to have to be Z. So A and B are either W or Y. Now, what we then want to do is look at the lower quartile and the upper quartile to see where those fall. Okay, so for A, for instance, your lower quartile, so that's going to be half of 15, about 7.5. It's nice that they split the grid into quarters. If we go across from there and go down, that's going to be just a little bit more than 150. So 153, 154-ish. While the upper quartile, go along to our graph and go down, is going to be about 166, 167. Okay. Now if we do the same with D, so go across our lower quartile, go down, that's about 145-ish. Okay, and then the upper quartile, go across and go down, that's about 175-ish. Now that from D suggests to me that D is going to be W, and then A is going to be Y. Okay, so looking at your lower quartile, about 154-ish, okay, which is there, and the upper quartile about 165, 66-ish. Okay, so there. Okay, so just fill those in, and then we're done. D is W, B is X, A is Y, and C is Z. Super. Question 12. In a sale, the price of a jacket is reduced. The jacket has a normal price of £52. The jacket has a sale price of £41.60. Work out the percentage reduction in the price of the jacket. Okay. We need to work out what it's decreased by in terms of monetary value. So 52 subtract £41.60. I need to put my decimal places up here so I can subtract it. 0 take away 0 is 0. Can't do 0 take away 6, I have to borrow 1. 10 take away 6 is 4. 1 take away 1 is 0. 5 take away 4 is 1. So it's decreased by £10.40. Now that is £10.40 out of 52. Okay. Now, basically, if I have a calculator, I'll type this in and times that by 100 to get my answer. So what I need to do is basically work this out using a written method.
and I can do that nice and easily because the denominator is not a decimal. So 10.4 or £10.40 divided by 52. Doesn't go into 1, carry the 1. Doesn't go into 10, carry the 10. Decimal point. 52 into 104 goes twice. Okay, and then just bring the 0 up. No remainder, obviously. So 0.2 is equal to, times that by 100, 20%. Okay, and there's our answer, 20%. To prove algebraic, the difference between any two different odd numbers is an even number. Difference between any two odd numbers. Okay, now an odd number can be defined as 2n plus 1. 2 times something makes it even, and then add 1 obviously makes it odd. The difference between any two different odd numbers. Now they're different. It doesn't say they're consecutive, it doesn't say they're any way related, it just says different. Now, if n is one integer, then m, we're going to say, is a different integer. So we've got 2m plus 1, subtract 2m plus 1. We'll define it in the same way, but just with m in there. I'm going to show that's always an even number. Okay. Difference between them means subtract. 2n subtract 2m, and then we've got 1 subtract 1, which is going to give us 0. Now factorise out your 2, and then we've got n subtract m. So n subtract m is going to be an integer, a whole number, times that by 2 is going to be even. Okay. Put 3 dots, which means therefore, and then basically rewrite the question. The difference between any two different odd numbers is an even number. Okay. And actually at the start I should have said let n and m be distinct, so that means essentially different. Integers. Okay. Next question, write 0.624 reoccurring as a fraction in its simplest form. So first thing I'm going to do is let x equal 0.624 reoccurring. 2 and 4 are the only bits that are reoccurring here. Then 10x is 6.24 with those bits reoccurring. Okay, which is going to be equal to 6.242424 forever. Now we then need to make another number which also has 24 reoccurring by multiplying this number, or x. So if I times that by 10x by 100, that will move my decimal point 2 places to the right. So that's going to be 1000x. That's going to be 624.242424 forever. Then if we do 1000x, so this number, take away my 10x. Okay, 624 take away 6 is 618, and then the 0.24 recurring bits are going to disappear until we get 1000 take away 10 is 990, x is 618, x is equal to 618 divided by 990, and then we need to write it in its simplest form, the question says. So half both of those, we're going to get 309 divided by 450, it's half of 900, add half of 90, which is 45, so 495. Now, I just want to check at this point that I can't simplify that any further. I'm looking at it thinking that maybe I can divide by 3. I know I can divide 309 by 3. So let's try 495. Let's just check I can't divide that by 3. Goes in once, remainder 1. Goes in 6, remainder 1. 15 divided by 3 is 3. Just check that. So if I times that by 3, I get... No, sorry, that should be 5, shouldn't it? 165. 3 times 5 is 15, carry your 1. 3 times 6 is 18, add the 1 that you carried, is 19, carry the 1. Yep, that works, 165. So you can get, to divide that by 3. Um, 103 over 165, and then again I want to check I can't divide any of these by another number. Now I won't be able to divide by 3 because it's going to be 90 and then 93, 96, 99, 102. That won't work. Just thinking about my other prime numbers. Can't divide by 5. Can I divide by 7? 77, 84, 91, 98, 105. No. So I'm very confident that that is as simple as I can make that. 103 over 165. Here's a sketch of a vertical cross section through the centre of a bowl. Okay, so this being our bowl, and they've put it on a set of axes. The cross section is a shaded region between the curve and the x-axis. The curve has equation y equals x squared over 10 subtract 3x, where x and y are both measured in centimetres. Find the depth of the bowl. So we need to find the minimum point. Okay, we need to find that minimum point there. Now the best way of doing that is probably by completing the square. I'm just saying that because I've just done completing the square in lessons, and so I know you can do it that way. I'm just wondering if there are other ways. So you could find this point here, and then due to the symmetry, find the midpoint, substitute that in. That will give you the y value. You could do it that way. So you could do it by finding the other solution to this using maybe quadratic formula, if that will give you a nice number. Or, well, actually you can just factorise out the x, can't you, and do it that way. But let's try and do it with completing the square. So y is equal to, now I'm just going to actually rewrite that as 1/10 x squared subtract 3x. Okay, now because I've got this part in front of my x, what I'm going to do is I'm going to factorise that out. So 1/10 x squared subtract 3 times by 10 is going to be 30x. Okay, now I got 30 there because I thought, well, if I times 1 over 10 by 30, then I get back to 3. I was thinking, is it 3 over 10? Well, 1 over 10 times 3 over 10 is not going to be 3. So I needed to have something which, when multiplied by 1 over 10, gives me 3. Multiplying by 1 over 10 is the same as dividing by 10. Okay, now I need to complete the square. So I'm going to get in here x subtract 15 all squared. Okay, now that will give me x times x, x squared, minus 15x, minus 15x, or I should say, sorry, subtract 15x, subtract 15x. Now 15 squared, you may know this, is 225. And if you're not sure, work it out. 15 times 15, 5 times 5 is 25, carry your 2. 5 times 1 is 5, add the 2 is 75. And I'll do 10 times everything. So put the 0 there, 1 times 5 is 5, 1 times 1 is 1. Add those together, 225. So I need to subtract 225 off of here. Okay. And then I can multiply this all out. So 1 over 10 times by my bracket. I'm just going to leave it as it is, x minus 15 squared. And then 1 over 10 times this, which is going to be 225 over 10. I can simplify that. I can divide by 5. So I will simplify that because I think I may need that for the next bit. So dividing the bottom by 5, I'm going to get 2. And then 225 divided by 5. It goes in 0, carry my 2. Goes in 4, carry my 2. Goes in 5. I'm going to get 45 on the top, so 45 over 2. And all down here, just fill in my y's because that's still equal to y. Where x and y are both measured in centimetres, find the depth of the bowl. So the minimum point here, now the minimum point is going to be when this bracket equals 0, because if I square something, it can only be greater than or equal to 0. So the smallest I can make that is 0. Okay, so the lowest I can get down to is negative 45 over 2. So that's going to be my y coordinate. That's the smallest that y can be. So in terms of my coordinates, this minimum point I'm going to put here negative 45 over 2. I'm going to leave it as a fraction for now. And the x coordinate is when that bracket equals 0. And that bracket is going to equal 0 at 15. Okay, 15 taken by 15 is 0. Find the depth of the bowl. It's going down negative 45 over 2. 45 divided by 2. You're going to need a decimal point here. 2 goes into 4 twice. 2 goes into 5 twice, remainder 1. Decimal point, 2 goes into 10 5 times, 22.5. Okay, there we go. Now again, because that's 15 our x coordinate, this would have been 30. Okay, so if you factorise it, you get that. And then you could get that as 15 halfway because it's symmetrical. You could substitute 15 in, 15 squared, 225, divided by 10. Subtract 3 times 15, subtract 45. But remember, you don't have a calculator, so that's not necessarily going to be easier doing that calculation. M is the point such that B to M is BM to M to C is 1 to 2. So B to M is 1 to 2. So that's one part and that's two parts. Here is Charlie's method to find B to M in terms of A to B. Okay. B to C is B to A plus A to C. Okay. Now B to A, because you're going backwards, that arrow, so B is that direction. So if you're going the opposite direction, it's negative B. Okay, negative B. So negative B, add A is B to C. Now equals A, subtract B. B to M is half of B to C. Now we know it's not because this is a ratio, so that's one part and that's two parts. If it had been 2 to 2 or 1 to 1, then it would have been halfway. It's actually going to be a third, isn't it? Because one part there, two parts there. So that is actually a third, and that is actually going to be 2/3. So the top bit is right, B to C, but B to M is not half of B to C. To M is not half of B to C. It is B to C is 1/3. 1/3 of B to C. Okay. Next question, Martin expands this and he gets this cubic. Explain why Martin's solution cannot be correct. Now we could go through the process of multiplying this all out and doing it ourselves and seeing maybe what's right and what's wrong. Like exactly what's right and what's wrong. What we could also have a look at is the x cubed coefficient at the front here. So just make sure that's correct because we can do that quite quickly. 2 times 2 times 3. 2 times 2 is 4 times 3 is 12. So that works. And that is right. And then we can also check just the integer coefficient at the end here. The coefficient without any x squared. Just this final number here. So 1 times by negative 3 is negative 3. Negative 3 times by 2 is negative 6. Okay, it can't be correct. So let's write in full sentences. This isn't a question, so don't answer it with something like because or anything like that. Write a full sentence. Martin's solution cannot be correct because the final term is incorrect. It should have been negative 6 rather than positive 6. Okay. And that's just one reason why solution can't be correct. We could have expanded it all, and like I said, we could have found maybe the other numbers weren't quite correct. Okay, A, B, and D are points on the circumference of a circle. EDC is tangent to a circle, so EDC is tangent. Now, circle centre O, so this has to be a radius, which then means that those two have to be the same. Tangent means that's a right angle. Angle BDC
BDC is 57, so that's 57. Now straight away I can work out this angle in here. So 90 subtract 57, change that to an 8, carry a 1. 10 take away 7 is 3, 8 take away 5 is 3. So that's got to be 33 in here. This is also a radius because it goes from the origin to there, so which means that's got to be 33. Which means then that this is going to have to be 180 subtract 2 times 33, which is 66. I'm just seeing here, I must give a reason for each stage of my working. So what I'm going to do, I'm going to give this reason here. The reason I've done that is I know that tangent to a circle, start again, tangent to a circle and a radius meet at 90 degrees. Then this bit, 180 subtract 66, I'll work it out, then I'll put my reason down. Carry 1 over, 10 take away 6 is 4, 7 take 6 is 1, and then I've got 1 take away 0, so 114. So that's going to be 114. I'm going to put here angles in a triangle add up to 180 degrees. Okay, and I know I'm just gonna, because I haven't got any room down here, I'm going to put the reason I know that's 33. Angles at the base of an isosceles triangle are equal. Okay, and then I've got this angle here, which is going to be 180 subtract 114. I'll write that again. I've messed that up a little bit. Now we're just on 180 take 66 114, so this is going to have to be 66. The reason for that is angles on a straight line add up to 180 degrees. Okay, and then I could work out these two here, but actually I don't need to work those out. It says find this angle, find the size of angle A to O to B. So I'm work out this middle one, which is this one here, the one I just worked out, 66 degrees. Okay, done. Okay, the diagram shows the first 10 sides of a spiral pattern. It also gives the length in centimetres of the first 5 sides. The length in centimetres of the sides of the spiral form a sequence. Right, so let's write that down, that sequence. 1.5, 3, 5.5, 9, 13.5. Find an expression, and then obviously it will carry on as well. Find an expression in terms of n for the length in centimetres of the nth side. So really what we're doing here is working out the nth term. Okay, now the first thing you can think is, well, am I adding a number here, and if so, what number am I adding, and is it consistent? So I'm adding here 1.5, adding here 2.5, I'm adding here 3.5, and I'm adding here 4.5. So that's not consistent, but this difference, well, the second difference looks like it's going to be consistent, because that's adding 1, adding 1, adding 1. Okay, so I've got the same second difference, so it's an arithmetic sequence. Now what I then need to do is take this second difference and half it, so half of 1 is a half, and that's going to be my n squared term, so half of n squared. Now n squared is going to be, for instance, 1 squared is 1, half it is a half, or I'll put 0.5. Okay, I'm just going to line these up as best I can above our original sequence. 2 squared is 4, half it is 2. 3 squared is 9, half it is going to be, half of 9 is 4.5. Okay, and then 4 squared is 16, half it is 8. and then we've got 5 squared is 25, half it is 12.5. Now what I'm going to do is I'm going to subtract that sequence from my original one. Okay, so I'm just going to write here, subtract from original sequence. Okay, 1.5 take away 0.5 is 1, 3 take away 2 is 1, 5.5 take away 4.5 is 1, 9 take away 8 is 1, 13.5 take away 12.5 is 1, and so on. They should all be 1s. So really all I need to do is I need to do half n squared, and I need to add 1 onto it, and then I will get the original sequence. Okay, so my sequence there is going to be half n squared, add 1. And that's going to be an expression in terms of n for the length in centimetres of the nth side. A half n squared, add 1. Done. ABD is a right angled triangle. C is the point on BD such that angle ACB is 90 degrees. Let me just read that again. So A to B to D is a right angled triangle. Okay, we've got right angle here. C is the point on BD such that ACB equals 90 degrees, so I can also put 90 degrees on the other side, so ACD is 90 degrees. Prove that ABD is similar to triangle CBA. So ABD is similar to triangle CBA. ABD, the big triangle, is similar to this smaller triangle. Now they've got a shared side. Okay. And they've got a shared angle, that 90 degrees. In fact, they've got 2 shared angles. So they've got 2 shared angles here. They've got the right angle and they've got this ABC angle that's shared. So what we've got is angle, side, that is the same. Now if those 2 angles are the same, which means this angle must also be, well, that angle must be this angle. Okay, now at which point all 3 angles are the same. And if all 3 angles are the same, then they must be similar. Okay. Okay, so how could I write this down? Angle, and this is a way of writing an angle. Actually, I'll write it in words. Angle ACB is equal to angle DAB, angle CBA is equal to angle CBA. Okay, that's a shared angle. Perhaps I should have written for that, instead of writing it's the same as itself. Seems a bit illogical. Angle CBA is a shared angle. For triangle ABC and triangle ABD, and this angle here must be the same as this angle. Okay, so angle A, sorry, not A, BAC must be the same as angle, move that over so that you can see it a bit clearly, a bit more clearly, as angle ADB.
since the other two angles in, so BAC is in triangle CAB, in triangle CAB and triangle ADB are respectively, I should say, respectively are equal. Okay, so there's a shared angle there and they both got a right angle, which means the other angle in each of the triangles must be the same. Okay, because you've got 180 in that triangle, take away 90, take away this one, and in this big triangle you've got 180 take away 90, take away this angle, so that other angle in each of the triangles must be the same. Therefore, as all angles are equal in triangles C, B, A and A, B, D, they must be similar. Okay, there we go. And I've only crossed that line out because it didn't really make much sense to write it, although I knew what I meant when I was writing it down. It doesn't make much sense to write that angle is the same as that angle. Okay, it's the same, it's a shared angle, isn't it? Solve this algebraically. Okie dokie. Right, so probably the best thing to do for this is to substitute in for x squared or y squared. So I'm going to call this equation 1, this equation 2. I'm going to rearrange equation 2 to give me x equals 2y, subtract 3. I'm going to do that by adding 2y to both sides. Okay, and I'm going to call that equation 3. Now, then what I want to do is substitute 3 into equation 1. Okay, so we're going to get 2y subtract 3 is going to go where my x is, because x is equal to that, and I'm going to square it. I'm going to add y squared, and then that's got to be equal to 18. So then I've got to square these two brackets, or square this bracket. 2y subtract 3 plus y squared is equal to 18. So 2 times 2, 2y times 2y, negative 3 times negative 3, 2y times negative 3, and negative 3 times 2y. That's going to give me 4y squared, subtract 6y plus 9 plus y squared, because that's come from there, is equal to 18. Okay, now that gives me 5y squared, subtract 12y plus 9 is 18. Now take 18 off both sides, and you get 5y squared, subtract 12y, subtract 9 is equal to 0. Now we can't use quadratic formula for this because we haven't got calculators. So I could think about factorising, and well, I am thinking about that because I need to solve it and I need to get an answer for y, or two answers I'm going to get most likely. Well, I am, because I've got to have 5y in one bracket and I've got to have y in the other bracket. Now because I haven't got my calculator, I'm going to assume that this will factorise nicely, as then my only other option is completing the square. Okay, so my factors of 9, I've got 3 and 3, and I've got to have plus 3 and negative 3, or I've got 1 and 9, so one of those numbers would have to be positive and one negative. So if I put plus 3 here, 5 times 3 is 15, that's not going to get near negative 12, so negative 3 here, 5 times negative 3, negative 15, 3 times y is add 3y, that will do it. Okay, so there we go. 5y times negative 3 is negative 15y. 3 times y is 3y. Add them together, you get negative 12. 3 times negative 3 is 9. Okay, so that gives me that y is equal to 3 from this bracket, or y is equal to negative 3 over 5. I know that because if I substitute that in as y, negative 3 over 5 times 5 is negative 3, add 3 is 0. Okay. Substitute, I'm just going to abbreviate there, y equals 3 into, let's go, well, we're going to have to go with equation, we'll go with equation 3 because that's the nicest. And then we get x is equal to 2 times 3 minus 3. So x is equal to 2 times 3 is 6, take away 3 is 3. Okay. And then substitute y equals negative 3 over 5 into 3. X equals 2 times negative 3 over 5, subtract 3. So x is equal to 2 times, so negative 6 over 5, subtract 3. 3 is going to be 15 over 5. Okay, now that's going to be equal to, I'm going to work left to right now so I don't cover up the answer line. Negative 6 subtract 15 is negative 21 over 5. Okay, yeah, 6 add 15 is 21. Negative 21 over 5. Now if I had a calculator I would substitute these back in and check them in both equations, and if I have time at the end of the exam that's what I would do also to make sure these work. Okay, so now I need to write all my answers on the answer line. So x equals 3 and y equals 3, or x equals negative 21 over 5 and y equals negative 3/5. Just going to write that again up here just for the space. Y equals negative 3 over 5. Here you go. You don't want to. You want to make sure the examiner can see the negative and they can see your fraction and all your numbers and all your answers. Okay, so there we go. What I will do, just to check and make sure I haven't made any mistakes, and this is what I recommend you to do if you're at home and you're working through this yourself, or when you're working through it, is grab your calculator. Obviously you won't have this in the exam, but it's good to make sure you can check, and also if you have made a mistake you can then go back through and try and work out where you made the mistake, so then that will help with checking your own work. Okay, so I'm going to substitute in negative 21 over 5 and negative 3 over 5 into this first equation, because I'm thinking, because that's the one I've used, that it will work with 3. I need to try 1 and 2. Okay, so when you square it, make sure you put it in brackets because it's negative. So negative 21 over 5 all squared. And obviously, again, if you had time in the exam, you could try and do this without your calculator. And then negative 3 over 5 all squared. And then that should equal 18 if we've done it right. And it does. Okay, so it works in that one, which suggests to me that it should work in this one, but we're still going to check. So x is negative 21 over 5. Okay, negative 21 over 5. Subtract 2 times. I'm going to put it in brackets now because I'm doing something to it. I'm multiplying it by something. Y, which is negative 3/5. Negative 3, which is what we should get. Okay, yeah, so that is right. Always worth checking, just so you can go back and check your work if you need to. And like I say, if I had more time, if I had time at the end of an exam, that's what I would do. The first ones, obviously, because they're nice integer whole numbers, my inclination is that they are going to be right, but it's more easy to make mistakes with the fractions. especially without a calculator. Okay, show that this can be written as this. So essentially we're rationalising the denominator. 3 plus root 2 over 5 plus root 8. Now to rationalise the denominator, you need to multiply top and bottom by the conjugate. So 5 minus root 8 over 5 minus root 8. Because it's the same on the top and the bottom, it's not going to change the value. So if we do that, now I'll put these in brackets, so then it's like expanding out a quadratic. Okay, 3 times 5 is 15. Okay, and then I'm going to do 3 times negative root 8, so subtract 3 root 8. Root 2 times 5 is plus 5 root 2, and then root 2 times by root 8, and it's a negative, so subtract 2 times 8 is 16, so root 16, and we'll sort that out in a second, but you may have realised already what that's going to be. 5 times 5 is 25. 5 times root 8, negative root 8 is going to be subtract 5 root 8, and then root 8 times 5 is plus 5 root 8, and then we've got root 8 times negative root 8, which is going to give us negative root 64. Okay, and then we've got 15 on the top, and then we need to sort out that root 8. So root 8 we can simplify, and you may have already noticed that. Root 8 is going to be, if you know this, 2 root 2. So 15 subtract, now we've got 3 times 2 root 2, because that's 4 times 2 is 8. Square root of 4 is 2, so you can bring that outside as 2 root 2. Plus 5 root 2. Square root of 16 is 4, so subtract 4. All divided by 25, subtract the square root of 64. Though these are going to cancel out. 25, now the square root of 64 is 8, subtract 8. 15, 3 times 2 is 6 root 2, plus 5 root 2, subtract 4, over 25, subtract 8, which is going to be 17, and so finally we get 15 take away 4 is 11. Okay, negative 6 add 5 is negative 1, so negative root 2 over 17. Okay, there we go, and then I'll put the square, which means basically I'm finished. I've shown it, I've done. The graph of this function is shown on the grid. Graph A is a reflection of the graph y equals f of x. Okay, write down the equation of graph A. So basically all of our x coordinates have become the negative version, so well, negative x has become positive x. Okay, so x has changed to negative x, so what we need to write down is y equals f, and we'll just change x for negative x. Okay, y is f of negative x. Okay. Right, this graph is shown on the grid. Graph B is a translation of y equals g of x. Now it's shifted up. It's gone. So if you look at, you can pick any point out, any two corresponding points. But if you look at the origin, that's gone up to 1 here. So it shifted the whole graph up by 1. Now this function here, this is going to work out your y value. So your y value is g of x. So we want it to work out the same value for g of x, we just want it to add 1 to each of them, so our y value increases by 1, so y equals g of x add 1. So same function, same thing, just add 1 to it on our y value. This will make y 1 higher. Okay, y equals cos of x degrees. Okay, this is cos. Now this is going to go through. So this is obviously our origin, this goes through at 1, and this bottom or minimum point is going to be negative 1. Now, sine and cos are cyclical functions, which essentially means they repeat. They repeat every 360 degrees. Now you can see here, that is coming up, it's like it's coming up here, and then it starts again. So that's going to be 360. Now, that's symmetrical, so that's going to be halfway. Half of 360 is 180. Write down the coordinates of the point marked C. Well, we've got it now. It's going to be
180, negative 1. Okay, y value is negative 1. Okay, now for this question, it says there are 20 members aged between 25 and 30. 25 to 30 is this bit. Now that's got a width of 5, so 5 times by the height of this rectangle is going to give us 20, so 20 divided by 5 gives us 4. So the height of this must be 4, which then gives us that each of these larger squares must be 1 unit. Okay, right, now I'll fill that in. So that represents 20 people. This is a difference of 10 times by 0.7. 10 times by 0.7 is going to be 7, so that's 7 people. This has a width of 1.5. Oh, sorry, 15. 15 times by a height of 2 gives us 30. This has a width of 20 times by 2.6. Okay, so 20 times 2.6. Well, I can write that as 2 times 26, which is going to give us 52. And then this last rectangle here goes from 50 to 80, so a width of 30, and you've got 30 times by 0.3. Okay, so that's going to be 10 times 0.9. Okay, let's put that 30 up into 10 times 3. 0.3 times 3 is 0.9. 10 times 0.9 gives you 90. Okay. Sorry, not 90, excuse me, 9. Okay, right. Now from there what we need to do is we need to work out the probability that this member is more than 30 years old. So more than 30 is 52 add 9, which is 61. And then we need to work out how many people there are in total. So 7 add 30, add 20, add 52, add 9. 9 add 52 is 61, add 20 is 81, add 30, we'll add 20 is 101, so 111, add 7 is 118. Okay, so it's going to be 61 out of 118. Now, what you then need to do is just make sure that can't be simplified. So I believe 61 is a prime number, so as 61 can't go into 118, as long as it is a prime number, then we won't be able to simplify it because it'll be co-prime. Right, so obviously 2 can't go into it, 3 can't go into it, because 3 goes into 60, 4 can't go into it, 5 can't, 6 obviously can't, 7 won't, because that goes 56, 63, 8 won't, because that goes 56, 64. Okay. So, yes, I think that's our final answer. There are 6 black counters and 4 white counters in bag A, 7 black counters and 3 white counters in bag B, 5 black counters and 5 white counters in bag C. Bernie takes at random a counter from bag A and puts the counter in bag B. So he's taking 1 and putting it in bag B. It's going to change probabilities. He then takes at random a counter from bag B and puts it in bag C. Find the probability that there are now more black counters than white counters in bag C. So they're even at the start, 5 and 5. We want the probability there's more black counters in bag C at the end, which means from bag B to bag C, he's taking a black counter and putting it in. Okay, so really, although we've got 3 bags here, we're only looking at a 2 kind of step tree diagram, where we're only really concerned about with bag B drawing out a black counter. Okay, this will be bag A, bag B, and then black counters and white counters.
Okay, probability of getting a black counter out of bag A is 6 out of 10, and then a white counter is 4 out of 10. If I get a black counter from bag A and put it into bag B, I'm then going to have 8 black counters in bag B. 8 out of the 3 is going to be 8 out of 11, so white out of bag B is then going to be 3 out of 11, although that's not going to matter, don't care about that. And then for bag B, if I get a white counter out, I'm then going to have 4 white counters in bag B, so that's going to be 4 out of 7 out of 3 is 10 out of the 1 that I've just put in is 11. So then probability of getting a black counter in this scenario out of bag B is going to be 7 out of 11. Now I'm only concerned about the scenarios where I get a black counter out of bag B. So white counters and then a black counter. So that's going to be 4 out of 10 times by 7 out of 11, which is 28 out of 110. Or the scenario where I get a black counter out of bag A and then a black counter out of bag B, which is going to be 6 out of 10 times by 8 over 11. 6 times 8 is 48 over 10 times 11, 110. So either of these two scenarios is what I'm looking for to answer this question. So if I add those two together, because I can have either of them, when you're thinking about OR in terms of probabilities, then you need to add your two or more probabilities together. So 48 over 110, add 28 over 110. 40 add 20 is 60, 68 add 8 is going to be 70, 8 add 8 is 76 over 110, which when I simplify that, I'm going to get on the bottom 55, divide by 2. Half of 70 is 35, half of 6 is 3, 35 add 3 is 38. Now you just want to make sure that you can't simplify that. So I need to think about my factors of 38, or just go through my whole numbers to make sure I can't divide both by any of them. So, for instance, can't divide by 2, can't divide by 3, the 38, or the 55, can't divide by 4, can't divide 38 by 5, can't divide 38 by 6, can't divide 38 by 7, can't divide by 8, okay, can't divide by 9 or 10 or 11. At this point I can be, pretty confident, very confident that I'm not going to be able to simplify it. Okay, and in fact that is the most simple answer.